Hi folks, welcome to today's video on sneaky tangent and normal questions. So we already established yesterday that what we really need to answer tangent questions or for equations of tangents is a point and the slope. If we're doing normals, then we just take that slope and take its negative reciprocal. I'd encourage you to try these questions on your own, and then if you get stuck, look through the solutions. So we're going to find the equation of the tangent on this that is parallel to y equals 6x. So they're telling us not about, a point. They're telling us about a different line that has a slope of 6. Okay, because y equals mx plus b is typically how we think of lines. Whatever's beside the x is the slope. So they're telling us slope, or gradient if you prefer, is 6. They're really asking us about this function here. They're saying you better find the place where it has a slope of 6 if it's going to be parallel to y equals 6x. So we're definitely going to have to differentiate. Negative 2, x squared becomes 2x to the 1, plus 8, x becomes a 1, and that's 0. Negative 3 becomes a 0. So we get y prime is negative 4x plus 8. Okay. And we want to find where the slope is 0. So we're going to not where it's 0, where it's 6. We're going to sub 6 for slope. Now, what letter here represents slope? You guessed it. It's y prime. Okay. That whole derivative reads the slope equals. So put in 6 here. And we'll have to solve this little equation. So that'll give us 4x equals 2. Or x equals a half. We're not done on the question. Really, we're at the point where we would normally start the question, where they'd give us the x value. We do know what the point of tangency is, or at least half of what the point of tangency is. We do know the slope. Those are the two things we need for the equation of any line. So the point is at x equals a half, and the slope we know is 6, because they told us it has to be 6. If we want to find this y value, where do we find that? We find it from the original y equals. I mean, it literally even says y equals in it. So negative 2, 1/2 squared plus 8 times 1/2 minus 3. In other words, that's negative 2 times a quarter plus 4 minus 3, or negative a half plus 1. And so that means the y value, incidentally, is also a half, okay, or as a coincidence. Now we're ready to roll. We know a point, we know a slope. What can we use? Point-slope formula. Bam. And we'll just plug and chug. Y minus a half equals 6 by x minus a half, or y minus a half equals 6x minus 3. And we can add that half to the other side and call this negative 2.5, I guess you could say. Or if you prefer an improper fraction, which I would, negative 5 over 2. Either of these are okay. Let's check it on Desmos. So first thing I'm going to do is draw y equals 6x. That's the line that I have to be parallel to. Next, I'll put in the actual function. So clearly the green one is not a tangent on the purple one. I don't think it even ever touches. So what we found was y equals 6x minus 2.5, or minus 5 over 2. Which it looks like is one that is a tangent to that purple one. And you can see it's also parallel to the green one. So it must be both parallel and a tangent on that graph. So we must have done this correctly. Desmos or your GDC can help you figure out whether the answer you got is reasonable and whether it has graphical meaning. Example 6. Find the equations of all horizontal tangents on this. So again, I'd encourage you to just pause and try this yourself. So horizontal means slope is 0. Okay. And a couple of videos ago, I left the lingering question, what is the most important slope? And the most important slope is probably 0, because that's where the magic happens on graphs. If you have a graph that does something like this, right here it has a slope of 0, right here it has a slope of 0. That's where your turning points are going to be, and we're going to exploit that fact pretty soon. Anyways, this is just asking us, where do we have horizontal tangents? In other words, where is slope 0? And then we'll find the corresponding equations. So we need an expression for slope at all. 2x minus 9 times 1. And that 2 at the end is a constant term, so it's going to turn into a 0. Okay. And so now we're going to sub 0 for y prime, because y prime means slope. So 0 goes in here. Oh, we are going to factor it eventually, but I don't want to start with that. 3x squared minus 6x minus 9. Greatest common factor of 3. You could either divide it out, or you could factor it out like this. Minus 2x minus 3. We'll factor some more. X minus 3 and x plus 1. So our x values that we care about are 3 and negative 1. That's actually not the end of the question. It doesn't just ask you for where they happen, but what their equations are. So for each one of them, we're going to have to figure out the point and the slope. So the point is 3 something, and this one over here, the point is going to be negative 1 something. Now, when I put 3 into this function, I'm just going to do a little scrap work off to the side. 3 cubed minus 3 times 3 squared minus 9 times 3 plus 2 is going to be 27 minus 27 minus 27 plus 2. Okay, so the y value is at negative 25. The other one, if I put in negative 1, I'd have negative 1 cubed. So what I'm doing here to find a y value is to sub into the original, the one that says y equals negative 3 by negative 1 squared minus 9 times negative 1 plus 2. So that's negative 1 minus 3 plus 9 plus 2 gives us gives us positive 7. Now that we know those y values, we can think about our slope. And they already told us the slope is going to be 0 at these points. So I can use point slope formula on each of these. Point slope formula, just to recap, is y minus y1 equals mx minus x1. So I'll have y minus negative 25 equals 0 times x minus 3. Or in other words, y plus 25 equals 0, or y equals negative 25. And because it's a horizontal line, of course it's going to be just y equals a constant. If you notice that property, maybe you could have saved yourself a couple of steps here of using point slope formula, but it's okay if you don't. Same with the other one. We'll have y minus 7 equals 0, x minus negative 1, so x plus 1. So we get y minus 7 equals 0, or y equals 7. Again, let's head to Desmos to confirm. So I've got my function in red. I really don't see enough of it, so I'm going to have to squeeze this down a little bit. And look at that. One of those horizontal tangents really does touch at x equals negative 1. And the other one does touch at x equals 3. And the y values are 7 and negative 25 respectively. That means we have some graphical confirmation that what we did is okay. And the last sneaky one, though I mean there are infinitely many sneaky brands of these types of questions. Find the coordinates of the point on this where its tangent is parallel to its tangent at x equals 1. Oh my gosh, we know very little here. We know something about x equals 1, and we need to know something about slope, so let's see. Y prime would be 3x squared plus 2x plus 1. Okay. And it says parallel to its tangent at x equals 1. So at x equals 1, y prime is going to be 3 times 1 squared plus 2 times 1 plus 1. Okay, so that means that it's going to be 3 plus 2 plus 1. That is the slope at x equals 1. And if we're parallel to the slope at x equals 1, well, that's just some other place where you have a slope of 6. So let's now sub 6 for y prime to find every place where it might have a slope of 6. And that's going to give us this little quadratic. And we kind of already know that one of the solutions for this is going to be positive 1. From this point, we can factor it, or we can attempt to use the quadratic formula. Either one's fine. If you factor this equation, you're going to get 3x and x in separate brackets here. We're going to need a minus 1 here. And we knew that because 1 was going to be a solution, which means we need a positive 5 here. So it's going to have solutions of x equals 1, which we already knew about. We're looking for the other place that this happens. So that's where 3x plus 5 equals 0, or 3x equals negative 5, or x equals negative 5/3. Okay, we're almost there. We found the x value, but we need coordinates. So the point is going to be negative 5/3 and some y value. And that y value is going to come from subbing in negative 5/3 in the original. And this may be a bit painful. And that's okay. We can still work through it. I have faith in us. Plus 3. Okay, and this is probably a good exercise in just playing with fractions. So that's going to be negative 125 over 27. This is going to be positive 25 over 9. This is going to be negative 5 over 3. And this will be positive 3. I think we're going to need a common denominator of 27 here. So negative 125 over 27. The other one we have to times by 3 on top and bottom. So that's going to give us 75 over 27. Next one we need to times by 9 on top and bottom. So that's negative 45 over 27. And the next one is the fraction 3 over 1. So you got to times top and bottom by 27. So there we go. Now we just need to add these up. Now sometimes what I like to do when I've got something that's kind of complicated is put all my negatives together and then all my positives together. So 75 plus 81 is 156. And then I can add this all up. So the difference is negative 14 over 27. That gives me my y value. Let's head to Desmos and just check this stuff out. So if we check the point at negative 1.66-ish, which is negative 4/3, we're around here. We're around negative 1/2, which seems about right. If I type it in as f of x, then you can see I can also double check my derivatives. I can ask it to find me f prime at 1, which is 6, and f prime at negative 5/3, which is also 6. So that guarantees that the slope is the same at those 2 points. There's a bunch of practice on page 233. 3, 4, and 5 are pretty reasonable. 1, 2, and 8 are a little more challenging. So take your pick there, but do try a few of these. I hope this has been helpful, folks. Good luck with the material, and take care.